video, we will discuss about 3 types of configuration. So, the number 1 is Fano plane, 2 is Pappus configuration, and last is Cremona-Richmond configuration. So, let's start at Fano plane. So, what is Fano plane? Fano plane is the smallest finite projective plane. It consists of 7 points, 7 lines, 3 points on every line, and 3 lines to every point. The standard notation for this plane as a member of family of projective spaces is projective geometry 2, 2, which Fano plane is a 2-dimensional and has an order of 2. It was named after Gino Fano. So, who is Gino Fano? Gino Fano was born in 1871 and died at 1952. He was an Italian mathematician, best known as the founder of finite geometry. And lastly, Gino Fano was an early writer in the area of finite projective space. So, this is the Fano plane. So, as we can see, it consists of 1, 2, 3, 4, 5, 6, and 7 points. Also, Fano plane consists of 1, 2, 3, 4, 5, 6, and the circle 1 is the 7th line. As you can see, there are 3 points on every line. Okay, so let's say this the line. There's 1, 2, and 3 points on it. Lastly, 3 lines through every point. Okay, so let's say this point is point A. Point A has 1, 2, and 3 lines through it. So you can see in point B, point C, point D, and so on and so forth. We can see that there are 3 lines in every point. So there are 5 axioms of Fano plane. Number 1, there exists at least 1 line. Axioms number 2, every line contains exactly 3 points. Axioms number 3, not all points are on the same line. Axioms number 4, 2 distinct points uniquely determine a line. Lastly, the axioms number 5, 2 lines intersect at least 1 point. Second one is Pappus configuration. So, what is Pappus configuration? Pappus configuration consists of 9 points and 9 lines. Pappus theorem. If N and M are parallel lines with distinct points A, B, C on M, and A prime, B prime, C prime on N, then the 3 intersections points if AC prime with CA prime, AB prime and BA prime, and BC prime and CB prime are collinear. Pappus configuration was named after Pappus of Alexandria. So, Pappus of Alexandria is one of the last Greek mathematicians of antiquity. Was active in the 4th century AD. The great work of Pappus in 8 books entitled Synagogue or Collection has not survived in complete form. The first book is lost and the rest have suffered considerably. So this is the Pappus configuration. As you can see, there are 1, 2, 3, 4, 5, 6, 7, 8, and 9 points. Also, it has 1, 2, 3, 4, 5, 6, 7, 8, and 9 lines. The Pappus configuration has 6 axioms. Axiom number 1, there exists at least 1 line. Number 2, there are 3 distinct points on every line. 3, not all points are on the same line. Axiom 4, there is at most 1 line on any 2 distinct points. 5, if P is point not on a line M, there exactly 1 line on P parallel to M. And last one, if M is a line, not a point, the exactly 1 point on M parallel to P. Lastly, Cremona-Richmond configuration. So what is Cremona-Richmond configuration? It consists of 15 points and 15 lines. 3 points on every line, 3 lines to 3 points, containing no triangle. Cremona-Richmond configuration is generalized quadrangle with parameters of 2, 2, which means it is two-dimensional and has an order of 2. It was studied by Cremona in 1877 and Richmond on 1900s. So, who is Cremona? So, Luigi Cremona was born on 1830 and died on 1903. He is an Italian mathematician. He devoted himself in studying geometry and reforming advanced mathematical teaching. He is noted for the important role he played in bringing about the great geometrical advances in Italy. Also, Herbert William Richmond was born in 1863 and died in 1948. An eminent geometer, one of his most popular work is an exact construction of the regular heptadecagon in 1893. So this is the Cremona-Richmond configuration. As you can see, it consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and lastly 15 points. Also, Cremona Richmond configuration has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is last and lastly 15 line.